Principle of electricity generation in primary aluminum air batteries. If there is aluminum in the saline solution as shown in this figure, aluminum cations will be released into the saline solution. At the same time, electrons flow to the carbon electrode at the cathode. The electrons react with the oxygen in the carbon electrode, or with the oxygen taken in from the air, to produce hydroxyl ions. The negative ions of the hydroxide are combined with the aluminum cation to produce aluminum hydroxide and hydrogen ions. The hydrogen ions adhere to the aluminum and cause aluminum corrosion. The series of work is completed. The energy born from the aluminum is returned to the aluminum with the help of oxygen. The energy flows from a high field to a low field. The value of the difference between the forces in that field is the voltage. And the magnitude of that flow is the current. For a rechargeable air battery, the function of the carbon material in the positive electrode is the same. Why is nanocarbon emulsion superior to the positive electrode in air batteries? If the oil in the emulsion volatilizes at the same time as the water, a porous material is created in the nanocarbon. This is where air accumulates. It becomes a pathway for air to pass from the outside. With Bario's advanced dispersion technology, any insulator can easily be uniformly dispersed into nanocarbons. Bario has the world's highest level of experience and craftsmanship. When it comes to defibrillation, exfoliation, and emulsification technologies, once the oil and water are volatilized, all that remains is a porous nanocarbon. In order to make the air battery a reality within 5 years, we need to make a positive electrode paste. Additives A are needed for gas diffusion. Additives B are needed for water repellency and reinforcement. Additives are insulating. For the cathode, which needs to be conductive, it is inconsistent. Graphite, graphene, is a gas adsorbent. This is inconsistent with gas diffusivity. Conductivity requires a graphite surface. To increase conductivity, single-layer CNTs with high aspect ratio are needed. DMR, iron catalyst removal, is necessary to defibrillate monolayer CNTs. A small amount of graphite, graphene, a large amount of MWCNTs and a small amount of SWCNTs are necessary to make air battery. With the addition of each additive, the advanced Bario technology of dispersing them is necessary for their exfoliation and defibrillation. With the right additives, Bario can make an optimal cathode paste for air batteries within a few months. With feedback, we can optimize our formulations and make more complete cathode pastes. Bario is the only company in the world with a patented nanocarbon emulsion and a DMR system that can defibrillate iron-catalyzed monolayer CNTs. There is no one else in the world who can operate the advanced dispersion technology. The nanocarbon emulsion technique is the most cost-effective way to improve conductivity. No oil, no nanocarbon emulsion. Relative resistance rate. Differential omega per differential centimeter is 1.1269. Nanocarbon emulsion. Relative resistance rate. Differential omega per differential centimeter is 0.624. All conditions are the same except for the presence or absence of oil. Raw material costs 195 yen per kilogram. Including water costs 110 yen per kilogram.